What's up, everyone? How's everyone doing, man? I hope everyone's having a great day, because I'm having a great day. And we're going to be talking today about log messages, right? So we're going to be basically talking about like how to identify issues on your computer, like if you're having any like hardware issues, system issues, whatever. I'm going to go to the main two sources, which is logs and dmesg, right? So the first thing you want to do is navigate to var log. I'm already there, so that's why. Obviously, it says log right here. So I'm going to list everything in my directory. So the first thing we're going to have is auth log. So the authentication log. So someone got denied or they have access. The boot log information. Mail log, anything related to the mail server, right? Cloud.net log, since I'm on an EC2 Amazon virtual machine, that's why that file exists, right? If we use a cat file, you can look inside the file without actually using an editor. So you can use cat cloud.net. You get like a little preview. Actually, you do get a preview of the whole file. So there's all the information pertaining to when the cloud was initialized. And that's pretty much it for logging, right? But logging is not going to tell you everything. And the reason why is because when the computer starts, basically what happens is that before like in the very early stages of initialization, logging daemons, which daemon means programs, and that's what in Linux is called. A daemon is basically a program, right? So anything such as syslog or rsyslog, they're not up yet. And to avoid losing notable error messages and warnings from this phase of initialization, the kernel contains a ring buffer that uses the store message store, or uses it as a message store, basically. So let me explain what a ring buffer is. A ring buffer is a memory space reserved for messages. It is simple in design and of a fixed size, right? So when it's full, newer messages overwrite the older ones, right? That's why it's called a ring buffer, because it's a circle and it overwrites the older data because it's going in a circle, right? So the kernel ring buffer stores information such as initialization, messages of device, drivers, messages from hardware, and messages from kernel modules. Because it contains these low-level startup messages, the ring buffer is a good place to start an investigation of hardware errors and other startup issues. So we're going to go with dmesg now. So I'm going to explain to you how it works. So this right here on the left side is telling you how many seconds had elapsed since the actual kernel has been started, right? So it's 20 seconds, and these are the nanoseconds, right? And these are all the events that happen. If this is a little bit confusing, use a -T, capital T, which is basically human timestamps. That's what it stands for. So yeah, so human readable timestamps specifically, right? So this is going to tell you exactly when this event occurred. The only downside is I'm going to tell you how long, like basically how many seconds in or how many minutes in this occurred. So that's why you use the regular dmesg command, right? And then from here you can just get the number of seconds, and then you can divide that to get your minutes and stuff. So like I said, all that gives you the date and time when it occurred and what occurred. So for dmesg, and like I said, that's why dmesg is really good, because it gives you all the information before the logging the logs have started. So that's why it's really important. One thing you can use is use dmesg --follow. So basically right now what --follow does, it watches the dmesg live. So when you run dmesg normally, it's static, meaning that it's just a file that's already has been written that you're looking at, right? So when you're doing --follow, it's live, meaning that when you plug in a USB, take it out, something happens in your system, it will start logging it automatically. We don't see anything right now, but let's quit out of it. Use Control-C to quit out of it. But I would just end this live log, meaning that as soon as something's written, boom, you can be able to see it on your screen. So that's pretty cool, right? So the next thing we want to talk about is how to search information in dmesg, right? So there's two commands. You guys can use tail, which will give you the last 10 lines of a file, and you can use head. It will give you the first 10 lines of a file. So if I'm using dmesg, I can use this, which basically is piping, which is redirection. I'm going to do another video on that for you guys so you guys can understand it. So basically what it's doing is getting all the output from dmesg that me and you saw earlier, right? And it pipes into this, it pipes it into the actual program that I want to use, or daemon, right? So let's say I want to use head, right? So all the output here goes inside us here as the argument, right? So it goes inside of head. Head usually gives you the first 10 lines. So you see, those are the first 10 lines of when it started. If I use tail, same thing. All the output from dmesg goes into here and it gets filtered out to tail, because tail is a program and it gives you the last 10 lines. So that's the first 10 lines, that's the last 10 lines. But if you want to get less lines or more lines, you can use dash. I can do 3. It'll give me the first 3 lines. I want to get the last 3 lines, I can use tail. So you guys can use this as you please. You want to do 10 lines, 20 lines, 30 lines, doesn't really matter, but this is how you use it. dmesg, and you pipe that into the program, tail, and tail does that, right? Another thing is, if you're searching for actual issues, you guys can use the grep, right? So same thing, all the output goes in the grep, and then use -I is case insensitive. So you can look for like memory issues, so you can type in memory, right? So right now they're not memory issues. Why? Because this is just showing you things that contain the word memory, right? So things that contain the word USB. There it is, right? But this is kind of giving you information. So like if you're following a certain a certain thing, you can use grep to follow it in the boot process, right? But the main command we're going to use is dmesg-l, which gives you log information, right? So let me explain the logs and how they work. So if you ever see -err, basically, or -l-err means error conditions. We have warning conditions. We have critical conditions. We have notice, basically just normal, pretty much it on notice. But it's a significant condition, but it's normal, but it's something important to look at, right? And then we have informational, which is info. And then we also have debug, which is debug level messages, right? So if we do error, it does telling me the errors that's happened. If you do warn, these are the warnings that it's giving me. Fail to add mmconfig information, can't access extended PCI configuration space. Found PM timer bug on the chipset due to workarounds for a bug. This clock source is slow. Consider trying other clock sources, right? IP tables, operation not permitted, right? Obviously, you guys can use this little comma and do both of them at the same time, so you can search multiple types of logs, right? So this L means log level. So what kind of logs are you looking for? Warning, critical, like we discussed earlier. But you can do warn and error. These are the main things you're looking for. So any issues that's happening with your computer will be in these two things. So warn and error. All right, and let's see what else. All right. So for the dmesg, I get the dmesg program, or I guess call it daemon. That's pretty much it. I mean, there's really not much we can say. We already went over going to var log. Var log has all the log information, right? So you can use cat to look inside the files. The reason you use dmesg is because dmesg has information that has not been recorded by logs yet, because logs have not even started yet. So there's no point of looking at the logs, right? If you can't get information about the boot process of what's going on. Use a -- follow to follow the actual dmesg live, so all the kernel events and all the things that are going on, system events and stuff. So that's why when you use a -- follow, you can plug in a USB, you can see it like pop in live, all that information. Or if you're running like a stress test or something, you can look at that live. The other thing you guys can use is the -l for dmesg. So the -l basically goes over all the logs. So you can look at warn, you can look at error, ERR. So they'll give you the errors and the warnings. Those are the main two ones you're going to be using when you're looking for issues or errors that's going on with your memory modules or CPU or whatever. And then you can use a -T, which will give you a human timestamp, so you can read when this event occurred. You guys can use uptime for history, right? Like how long it's been up. You can also use history also. This will give you the history of what commands have been typed in. So maybe somebody typed in a bad command or a good command, who knows, you can always use history for that. And then you can also use a exclamation mark. Let's say I want to do command number 39. I can type in 39. This is only useful if you have a really long command, right? But that's really pretty much it. Thank you guys for watching. If you guys have any other questions or anything, please let me know. And you guys have a great day. And thank you for watching again. Bye.